Hello and welcome. Today, we're going to gently pull back the curtain on something that works silently behind the scenes to make our digital world just a little more orderly. We're talking about XML schemas.
I mean, really think about it for a second. You book a flight on some website and boom, that event just instantly appears in your calendar app, perfectly formatted. How does that even happen? How can two totally separate systems built by completely different teams speak to each other so flawlessly? Well, at its heart, it's really a form of silent agreement. For one system to understand another, they've got to agree on a way to communicate, right? A structure they both recognize. It's kind of like a secret handshake that just confirms they're on the same page. And that shared language, a lot of the time, it's XML, the extensible markup language. Now, its job isn't to say how data should look, but what the data is. It labels a piece of info as a last name or a price or a date. But just having a language is only the first step. You also need rules for how to use that language correctly.
And to make sure everyone's using that language in the same way, you need an official rulebook. For XML, that rulebook is called a schema.
Just imagine trying to have a conversation where everyone used their own, totally different rules for sentence structure. It'd be complete chaos, right? You need that agreed-upon grammar and syntax. And for the language of XML, the schema is that grammar.
So to get a little more specific, an XML schema, and you'll often see these as files ending in .xsd, is a document that defines the legal building blocks of an XML document. It sets the rules for the structure, what kind of content can go where, and even the super specific data types. It is, quite literally, the official rulebook. To really get this core idea, probably the best way to think about it is with a pretty simple analogy, a blueprint, versus the actual building.
Now, if you've done any programming, this is going to click right away. The XML schema is the blueprint, or a class definition. It describes exactly what a valid structure should look like, what its properties are, and all of the rules it has to follow. The XML document, then, is the actual building, or maybe the object created from that class. It's a real concrete thing that follows all the rules laid out in the blueprint. So let's break that blueprint down a little bit. First, the schema defines the structure, what pieces or elements are allowed, and what sequence they have to show up in. Second, it defines the element types. A simple type is easy. It just holds a piece of data, like the name John. A complex type is more like a container that holds other elements, say a contact element holding both a name and a phone number. And third, it gets super specific about data types, declaring that this field must be a number, this one must be text, and this one has to be a valid date. Now, schemas weren't actually the first attempt at creating these rulebooks. They had a predecessor called DTDs. But schemas, well, they brought some serious superpowers to the table, making them a really clear upgrade. This quote from our source material really just nails it. It points out the two biggest weaknesses of the old way, DTDs. They couldn't define specific data types. You couldn't say this must be an integer. And weirdly enough, they weren't written in XML themselves, which made them kind of clunky for programs to work with. And schemas just solves these problems so beautifully. They have tons of support for data types. They understand namespaces, which is basically a clever way to avoid naming conflicts if you're mixing different sets of XML tags. And crucially, they are written in XML, so the same tools that handle your data can also handle the rules for that data. Plus, they're designed to be extended so they can evolve over time without breaking. Okay, so this is all interesting technical stuff, but why does it really matter? Especially if you're, building a portfolio or heading into a tech career. Well, it all comes down to one core superpower, validation. You see, a schema's most critical job is to act like an automated inspector. It takes the blueprint, that's the schema, and it compares it against the building, the XML document, to make sure every single rule has been followed perfectly. And this is the reason it matters so much. It means that before an application even tries to process some piece of information, it can use the schema to ask a really simple but critical question. Is this data valid? Is it in the format I actually expect? And that one check, it's just incredibly powerful. This one simple check prevents a whole cascade of problems down the line. It stops errors before they can even start. Errors caused by missing fields, text being where a number should be, you name it. In any big system, from e-commerce sites to government databases, this kind of data integrity isn't just a nice to have. It is absolutely essential. All right, so let's just zoom out for one final thought here. When you look at the big picture, the whole concept is really quite elegant. All day, every day, these invisible blueprints are working in the background of so many things we use. They're the quiet enforcers of order, the reason why these incredibly complex systems can actually trust each other's data. They create a foundation of reliability that so much of our technology depends on. So, the next time you see that perfect, seamless exchange of information between two totally different services, maybe you'll take a moment to just appreciate the quiet, invisible structure, the schema, that made it all possible.